Hi, welcome to AB Video 1.4c, Part 2, Limits of Greatest Integer Functions.
To ask you what your age is right now, let's say you happen to be 17 years old. You would say you're 17, but in effect, you wouldn't really be 17 unless you were born exactly on this day, at this hour, at this minute. What you're doing, whether you're 17 years and 3 days old, 17 years and 4 months old, 17 years and 11 months and 30 days old, or 28 days old, you're actually giving me the greatest integer less than or equal to your age. And that's called the step function or the greatest integer function. Now on the TI there is no symbol. You can't, although we use the square brackets, on the TI if you want to do greatest integer function you have to know that it's int of x. You can actually just type in int open parentheses x close parentheses, or you can press the catalog, which is the little book button, and then press the letter I and scroll down. So, the definition, and sometimes they'll just use these brackets, and sometimes they'll add a little bar, or they'll make them really thick like they're boldface. But because of the confusion of that, they'll usually tell you this is the greatest integer function. So, the greatest integer function of x is the biggest integer less than or equal to x. Now, over here, pretty straightforward. The biggest integer less than or equal to 7.3 is 7. Biggest integer less than or equal to 7.994 is still 7. Biggest integer less than or equal to 7 is 7. Biggest integer less than or equal to 0.5 is 0. But you got to be careful when you're taking a negative. What is the greatest integer of negative 2.3? A lot of people go here, oh, well, that was 7 and that was 7. They think, oh, that'll be negative 2. Not good. Because if you place negative 2.3 on a number line, it's between negative 2 and negative 3. You want the biggest integer that is less than your number. So the biggest integer to the left of negative 2.3 is negative 3. So the greatest integer function of negative 2.3 is negative 3. Now the interesting thing about if you write out a greatest integer function, it's actually an infinite piece function. I know that sounds weird. But if you think of these as ages, when a baby is born until just before they turn 1 year old, if they could speak and you said, how old are you? They would have to say 0 years old because they haven't reached 1 year old yet. So from the day they're born, when x is 0, all the way to just before, like 1 minute to midnight before they turn 1 year old, they'll tell you they're 0 years old. As soon as they hit that day of their birthday, then they become 1 year old, and they will tell you, if they could speak, which they can't, but if they could, they'd tell you, I am 1 years old, I am 1 years old, I am 1 years old, right up until right before they turn 2 years old. So there's a lot of things in life that are end up being piece functions. For example, taxi rides or parking, because when you go for parking, it's not like they charge you, 17 cents per minute. You'll notice they charge you like 90 cents for the first 20 minutes and then $1 for each 20 minutes thereafter. So you pay for that first, 20 minutes, but as soon as you hit 20 minutes, as soon as it goes from 19 minutes to 20, boom, you jump up to the next level. Same thing with taxi fares. Now, how do you handle this when they ask you for the limit of a greatest integer function? I promise you these questions will be multiple choice, or I will tell you no work is needed. You can't actually substitute here, okay? So I think that's one of the most important things, is that we cannot substitute. Okay? You cannot substitute in this particular case. So, if you have a limit as x approaches 2 from the left, do not put 2 in here. Do not put 1.99 in here. But picture in your mind, think of a number very close to 2 on the left side of 2, such as a number like 1.99. So if you think about it, if I did take the greatest integer less than or equal to 1.99, my answer would be 1. If they ask you for the limit as x approaches 2 from... I already did that. Okay, this is what you don't want to do. Do not actually plug in the 1.99. If you approach from the right, picture something like 2.01, the greatest integer of function of 2.01 is 2. Now again, since the limit as x approaches 2 from the left of our function gives a different answer than the limit as x approaches 2 from the right of our function, that means the two-sided limit of the greatest integer function does not exist. If I actually go back to the graph, as you can see, this bug is not almost kissing this bug. This bug is not almost kissing that bug. This bug is not almost kissing that bug. Okay, looking at number 24, gets a little bit more complicated. The limit as x approaches 2 from the right of 2x minus the step function of x, or the greatest integer function of x. Now, for this part, you absolutely can substitute. You'll just let x equal 2, and you will get 4, yes? However, for this one, you have to think of substituting in a number very close to 2, but to the right of 2, such as 2.02. Think about what is the greatest integer of 2.01. The biggest integer less than or equal to 2.01 is 2, and therefore 4 minus 2 is 2. Okay. If you look at, yeah, I broke it up over here is what I did, so same thing. Instead, if it was the limit as x approaches 2 from the left of 2x minus greatest integer function, you'd have 2 times 2 is 4 by regular substitution, but for this you'd have to picture a number approaching 2 from the left, such as 1.9. Biggest integer of 1.9 is 1. So you end up with 4 minus 1, which is 3. Again, do not actually write this inside. You will lose points. Here's another one. Limit as x approaches 1 of 1 minus negative x over 2. So I'm replacing x by a number close to 1. So first of all, I can't figure out the two-sided limit until I find the two one-sided limits. So I'm looking for the limit as x approaches 1 from the left of this expression. So you picture a number approaching 1 from the left, such as such as 0.9. So this greatest integer function is negative 0.9 over 2. Well, 0.9 over 2 is negative 0.45. If you take negative 0.9 divided by 2, you get negative 0.45. And you're looking for the biggest integer less than or equal to negative 0.45. Well, of course, it sits between 0 and 1. So the biggest integer less than it is negative 1. So I said 0 and 1 is 0 and negative 1. And 1 minus negative 1 is 2. Limit as x approaches 1 from the right. The difference here is, instead of replacing x by 0.9, we're going to replace x by 1.1, some number to the right of 1. So again, my greatest integer function is the greatest integer function of negative x over 2. So I replace it by negative 1.1 over 2, which is negative 0.55. But I'm taking the greatest integer function of that number, and the greatest integer function of negative 0.55 is negative 1. So I end up with 1 minus negative 1 is 2. And again, your work is done at that point. Once the two one-sided limits are equal, then the two-sided limit is equal to that.
And that's the end of video 1.4c, part 2.